Yesterday we multiplied and divided rational expressions. Lauren, what are we doing? Some notes. You don't have your note packet, I know that, but I need to pay more attention. Okay, yesterday we multiplied and divided rational expressions. Today we'll finish up. We will add and subtract them. No. Alright. Can I add and subtract rational expressions? Steps to adding and subtracting. Guys, at the heart of rational expressions, don't I have just a thing over a thing? And then this will be plus or minus, right? Just a thing over a thing. That's what I'll have if you look down here. Is this just adding and subtracting fractions? What's the one thing I need to add and subtract fractions? A common denominator. That's what we're going to go for. We're going to try and get the least common denominator, but as with all adding and subtracting, we can do really anything that's common. As long as they're the same, I can add and subtract. So, the steps to adding and subtracting rational expressions. First, if I can, I want to factor the denominator. Sorry, I wasn't thinking right. And it's only the denominator. I don't want to factor the numerator because that will actually make my job of adding and subtracting and then canceling and combining like terms. It'll make it more difficult. So we actually want to leave the top unfactored. Alright? And if you can factor the denominator, do it. Only about half the time you'll be able to do that. So factor only the denominator if possible. It's a fun Friday and have it. So factor the denominator if you can. Then, if your denominators are not the same, if they're the same, you skip these steps. Look at our first few problems, they are the same. So skip these, all right? But you want to find what your least common denominator is. If I write LCD, do we know that means?
Yeah.
Liquid crystal display, right? That's what I forgot to do. Like, first block we were trying to figure out what LEDs did. I can't remember. Oh. No, light emitting diode. Light emitting diode. I just thought of it. Diode. No. You just heard of LED TVs or LCD TVs?
LCD is like what it is.
LCD is liquid crystal display. LED is light emitting diode. They sound like magical. Alright, guys, you want to find the least common denominator. If they're already common, skip this step. Before you think the third step is what? Actually multiply to make them your common denominators. First, I want you to find restrictions. So we'll put that as part of step 2. So find what your least common denominator is going to be, what you're going to go for, and then state your restrictions. Then I actually want to multiply to get common denominator. Common denominators. Now, what do I actually multiply always? I'll multiply by 7 over 7.
Multiply by the denominators.
Well, hold on. I'll multiply by a lot of different numbers, but what does that number always equal? It has to be 1, right? So the top and the bottom will be the same. So I have to multiply by a form of 1. To actually get my least common denominators. So that's step 3. I will actually do that. Yes. By a form of 1.
Form of 1. 7 over 7 is 1. 8 over 8 is 1.
If you multiply
just 1. 2.5.
No, if you multiply by 1, you wouldn't actually get anything. But if I multiply the bottoms by, say, 4x squared, I need to multiply by 4x squared over 4x.
Okay.
All right, so you guys have done this with fractions. You'll be fine. Okay? After I do that, all right, so I have common denominators, so I can actually add. Okay? I'm just going to add across. All right? Then, and this is the crucial step, because most of our instructions will be to perform the operation and then simplify. We waited till the end to do this. We didn't do it before. I want to factor the numerator. And simplify. Okay? So you wait till the end to factor your numerator and start canceling things out. Don't do it before. Alright, let's see it in action. I'll never give myself enough room. Let me know when I can erase 4 and 5.
Wait.
Wait. Is this what you got for A?
Bring out your mind.
I'm literally about to do it. Alright. So, letter A. Perform the indicated operation, simplify state restrictions, show your work. Okay? So, what was step 1? Factor the denominator only. So, those denominators are already factored, right?
Yeah.
So I'm going to skip step 1. What's step 2?
Find LCD.
Find least common denominator. Are those already? Yeah, they're already common, so no point in changing them. So state restrictions. What can x not equal?
-1.
Negative. All right, step 3.
Multiply by a form of 1 to get LCD.
So again, I already have my common denominator, so I will skip this step.
Add across.
Good, so add across. So I'll have 4 plus 2x minus 2 over x plus 1. Right? A lot of people, when we were doing adding and subtracting like fractions with radicals and stuff in chapters 5 and 6, would also add the bottom. So if I could do that, I wouldn't be worried about common denominators. So if that's something you do on a regular basis, fix that. Don't do that. Come see me if you need help with that. Sorry.
So then can you not add 4 to -2?
Good. So now, well, I'm not done yet. So this will equal, right? So I'm going to switch it. I'll have 2x, right, plus 2. Right, so 4 minus 2 is 2, and that 2x is by itself. I flipped them in terms of order. It would be wrong if you gave it to me the other way. Good, so what's my last step?
Factor numerator.
Oh, wait, guys, this is going to be the thing we forget, is to factor at the end and simplify. What can I pull out of 2x plus 2? 2, leaving me with
X plus 1.
x plus 1, and you're already seeing it, x plus 1. What's going to go away? So this answer is just do it.
How did you get the 4?
So that's just 4 plus 2x minus 2.
That's true, you're right.
You see that? So I literally,
Oh, you
yeah.
divided. When you do -2, add something. Keep talking. Keep equal to
Whatever.
2. Okay, so how did you perform?
So I added it here. So I got a 4, a 2x, and a negative 2. Since it's adding, I can just do that. It's not multiplication. That's adding. So I'm just combining my
So
terms.
basically the first
So if you had 4 minus.
Yeah, they go away. The reason I write the parentheses is when I get to subtracting, guys, that negative sign that'll be here instead of addition has to be distributed, right? So that's why I write the parentheses there. They go away, right? You can add that super easily.
See, that's why I want to fix it. I like grade tells me to distribute and not.
That's only what?
My grade tells me to distribute and not like add.
Well, because
Like
there's,
that's, yeah, that's
but
why
there's
it's so
this
straight
plus,
from
yeah.
formulas.
So, I'd be okay with you not writing parentheses, but when you go to subtraction, that worries.
Okay.
Because I see all kinds of people just carry the subtraction sign of this first term, not all. Cool? Alright, keep going. 8 plus 6t over 3t minus 3t minus 7 over 3t. So what's step 1? Factor. Can I factor? Yeah, 3t is done. What's the other thing about them that I can skip? They're already common. So I'm going to skip all the steps that have to do with factoring these common denominators and go straight to what, Christian? Straight to what? What's the next step? No. Guys, way too much talking going on. So, what's my only restriction here? Can't equal 0. Good, so now we don't add, we're subtracting. So guys, when we're subtracting, this is why the parentheses are very important. 8 plus 6t minus, and then I'm going to put that in parentheses, because 3t minus 7 over 3t. I need to take that minus sign, distribute it here, and distribute it here, right? So this becomes 8 plus 6t minus 3t plus 7. No, in terms of showing me work, no, I'd be okay if you did that, as long as you're very aware of distributing and everything like that. I see way too many people just give me the negative sign and negative 3t, and then minus 7 again, where the negative goes to all of it, right? It's the same when I do addition. The addition sign goes to all of them, but addition doesn't change my signs, so I'm not that concerned with it. It's when we get negatives with respect to really. So good, this is all over 3t. Let's combine terms. I've got 6t minus 3t. That's going to be 3t. 8 plus 7 plus 15 over 3t. No, these 3t's don't cancel, guys. They don't just cancel because there's this little addition sign here, or if it was a minus sign, they wouldn't cancel. The way I work to get them to cancel, I kind of hate how every time I switch between games it changes size. The way I get this to cancel is my last step. Brent, what's my final step? Back to the numerator. What can I pull out of that numerator? A 3? If I pull a 3 out, what do I get? T. Plus 1. Good. Over 3t. Now, Gigi, what cancels there? Just the 3's. The t's still don't cancel. Let's straight back to leave me with t plus 5 over 2. How would I take a t out of t plus 5? You would get t times 1 plus. I can't pull a t out. That's it. Nothing else cancels.
Wait, why is that a plus 7?
Minus, and it has to distribute.
Oh, I see.
That's why we do the parentheses. Come on. Good. Gigi thinks we should skip C because it's the same. Now, I agree that x squared plus 5 and x squared plus 5 are the same denominator, but what can I do to those? I can factor those. What can I pull out of x squared plus 5? Good. So 2x over x plus 5? Good, so I've factored, my denominators are still the same. Factoring shouldn't change your denominators if they're already equal, right? We should be fine there. So this is 2x minus x, which is just going to be x, right? Over x plus 5. So what did I not do, though? I didn't say restriction, my bad. Luckily, we're okay. I can do it here. So x can't equal 0 or what? Negative 5, right?
Okay.
Wait. How do you get this back?
I pulled an x out of x squared plus 5x. Back to the denominator possibly step 1. Good, what goes away? Yeah, the x's, leaving me with 1 over x plus 5. James?
Where did you get the 0 from? Was it because of the 2x and x?
No, it's because of these here. So set
the
e.
x that's outside the front.
Yeah, the x outside in front of it. That's still a factor. Right, I want to take every factor that has an x in it, set it equal to 0. That's my restriction. So x equals 0, 0 is my restriction. All right. Perform the indicated operation and simplify. State the restriction, show your work. 3 over 4x plus 2 over 8x squared. Guys, remember, so if I had, let's say, like 1 over 7, and I wanted to add that to 2 over 4. Okay, so if I can, I just want to work with one of my equations, right? Like, let's say this was
An 8.
Let's say this was 2 over 12. Would I do anything to this guy?
No, man.
No, I'd go here, multiply it by 3 over 3, right? So when you're finding least common denominator, if you can work with just one side, if you can go, I bet I can make that look like that, do it. So on this problem, I've got 3 over 4x plus 2 over 8x squared. What is step 1? Factor. Can I factor anything here?
No.
No, nothing's getting pulled out of there, so Lucky, what's the next step?
Make a common denominator.
Find the common denominator. All right, so here's what I do when I approach common denominators. I find the bigger one, and 8x squared is bigger because 8's bigger, but also it's the higher term, right?
Isn't it a multiple for us?
Hold on. So look at I want to find the bigger one, say, can I make the smaller one look exactly like the bigger one without having to do anything to it? Yeah, so if I multiply 4x by 2x, right, I'll have an 8 and an x squared. So I'm just going to multiply top and bottom by 2x over 2x. That's my form of 1. Whatever I multiply the bottom by, got to multiply the top by. So before I actually multiply, what do I need to do? State restrictions. What can x not equal?
0.
Good, so let's multiply it. 3 times 2x, 6x over, and I already know I'm going to get 8x squared plus 2 over 8x squared. So next step, I'm just going to add x. This is just 2 plus 6x over 8x squared. So Lauren, what's my last step? What do I always do last? I've added or everything. Factor the numerator specifically, right? Take out a 2. All right, I like that. Leaves me with what?
3x.
1 plus 3x. If you switch that to 3x plus 1 because you're like me and would rather see the 3x's first, but I'll live with it here. I'm okay with that. So over 8x squared. So it's not gonna cancel, it'll reduce, right? 2 over 8 will reduce to 1 over 4. You don't have to write the 1. So 3x plus 1 over 4x.
Cool. Doing every example.
Every single one. Just because I was gonna stop right now.
Maybe I
No,
won
I
it. Maybe I won.
was gonna keep going. Well, then you got your wish. Right, good. 1 over 2x cubed minus 4 over 3x. All right, first step. Factor. Can I factor this? No, anytime. If you don't have a plus or minus, guys, you'll never be able to factor. Good, so let's find the least common denominator. Guys, find, there's a couple ways you can do this, all right? Already I can look at this and tell them you have to work with both sides, right? Can you make a 2 into a 3?
Yeah.
No, it's very difficult, right? And you can't make a 3 into a 2. the x and the x cubed are pretty good, you know? So I already know whatever I multiply over here, it's going to have to be x squared, right? And then I know what's over here is going to not have an x, right? That's great. Good, and so then how do I make 2 look like a 3 and 3 look like a 2? I make them 6s. That's one way to do this, and I'm okay with that. The foolproof way to go for these common denominator guys is to multiply. I'm going to write it down here. So 2x cubed minus 4 over 3x. Guys, the foolproof way to do it is when you set up your multiplication, multiply it just by the other thing. So 3x over 3x, 2x cubed over 2x cubed. That's foolproof. That will work every time. Now, it's not the least common denominator, but it is a common denominator, and it's relatively small. And when we go to the end and we factor out the numerator to cancel, you'll get the exact same answer. This is foolproof. This will work every time. This you kind of got to see, right? You know, you have to. It's not too hard to see. Well, 2 and 3, I'm going to get the 6 and the cubes and all that. Now it's not so bad. Some of the later ones are a little more difficult to see, and so if you're just not finding it, just multiply the bottoms by each other on the opposite side. Lucky?
I was gonna ask about the x's, but I'm just looking.
You good?
I was gonna say, isn't that like the same thing? But
What, this? Yeah, the only thing this does is it adds an unnecessary x.
yeah, well, won't that factor out?
Yes, that's what I'm saying. Yeah, at the end when you do, you'll get the exact same. Not even, oh, it looks a little different. You'll cancel it. Good. So 3 times 1 is? 3 over what?
6x cubed.
Good. 6x cubed minus
8x
8x squared over
6x cubed.
equals.
Don't use the restriction.
Oh, dang it. Yeah. I could do it here, and I'd be fine, right? Guys, if you listen up, if when you're going to do restrictions, if you like did what I just did, you were going and you were multiplying and you did this, because you're multiplying by 1 over 1 essentially. Good. Because you're multiplying by 1 over 1, you can state your restrictions really at any time before you cancel at the very end. As long as you do it before then, you'll be okay. Just so you know. Good, so 3 minus 8x squared over 6x cubed. Done?
No.
No. What do I need to do, Christian? Yeah, I need to factor the numerator and reduce. What can I pull out of? Oh.
Pull out of.
What can you pull out? Oh, yeah. Okay. Yeah. Yeah. Yeah, guys, there's nothing I can pull out of 3 minus 8x squared. So I'm done. Nothing I can pull out.
Did you state your restrictions?
Yeah, I did up here, right? Do see on your own.
Earth, wind, and fire are coming. Earth, wind, and fire is coming, but they're taking some people to the $100.
So what am I going to multiply each side by? What did I multiply the left by?
4x to the 5th.
4x to the 5th. Over 4x to the 5th, right?
Yeah.
What did I multiply the right side by?
3.
3 over 3?
Yeah.
Yeah, that should work, right? Lucky, what does that leave me with?
Oh, it's a number less than that, more than that. It's like
15.
I don't know.
Like it.
So,
Over 12x.
So this leaves me with, first off, 4 times 4 is 16. X to the 5th over 12 x to the 5th plus 15 over 12x to the fifth. Good. So then we get 16 x to the fifth plus 15, that's a plus, over 12x to the fifth.
Your restriction is 0, right?
Yeah.
Oh, I didn't think about it.
Yeah, we should.
So that's the final answer.
Good. That's the final answer, guys. When I got to everything up here,
I never mind.
when I got to everything up here, I couldn't cancel until I had factored. Guys, technically, isn't this in parentheses?
Oh, wow, yeah.
You can't just take this and go, oh, I know, I'll just divide those out.
Wait, can't you do that and then put 12x to the fifth under the 15? Or can you not?
You can split the term.
Yeah. That's what you doing the most.
I want answers in C
Then, like, you
first,
just
so
get back
that's
to
not
where you
actually, and that's not actually any simpler in your back where you were, so that's not,
So you can only divide that by 3, which
Right.
would multiply.
because lucky, then you come around full circle and just giving me a fraction plus a fraction. So you're not,
Yeah,
you
right.
haven't actually done that equation at all. So I cannot just reduce those. If you're wondering, can I reduce this or not? Say, is it one term that I'm reducing all of, canceling all of them? That's why we factor. All right.
They use the word, okay?
So it's an
Yeah, that is literally the answer. 16 x to the fifth plus 15 over 12x. Yeah. Alright, perform the indicated operation. So get no. State the restrictions, show your work. So, first step. One is the first step. What is the first step?
Factor denominator.
Factor the denominator if possible. So, Carly, how am I going to factor those? Thanks, Carly. Yeah, you cannot factor those, guys.
No problem.
You're welcome.
No, it can factor. So Hannah asks, is it never going to factor when it's addition? Look ahead. Those are going to factor, right? Those are definitely going to factor. That one isn't, but that guy is. So no, the addition, the subtraction, multiplying, dividing, that has nothing to do with whether it can factor or not. I just start with the ones we can't factor and let's get the rest of the part, right? So I can't factor that. Are the denominators the same? No. Okay, so let's think. We have 1 over x plus 3 over x plus 2. That entire thing, x plus 2, it'd be really great if on the left side, I could just say plus 2, right? That'd be awesome, but I can't just add 2. The only math I can do to these expressions is just to multiply by 1, right? I can make the 1 look different, but I can't just add 2. So I've got to, yeah.
You do times x plus 2, and you do times 3.
Good. So just because I am making them look different, I have just an x and an x plus 2. That doesn't mean that I can't go back to my method, right, of multiplying each side by each other. Right, so that's that, leaving me with 1 over x, cut it out, Christian, x plus 2. Are you kidding? X plus 2, right? That it?
What? Oh, no. No.
No?
No.
X squared plus 2.
The top of the...
Oh, the top. I didn't know if that was top. That was silly, isn't it?
I thought you were like having a trick question.
Nope. I was just wrong. Good, so now we can do restrictions, right? Good, so the restrictions don't change. That's the one nice thing about this, is I can do it here, I can do it here. Anywhere I do the restrictions, it'll be okay, as long as I haven't canceled something. Okay, so x cannot equal 0 and negative 2, right? 0 and negative 2. We got the same thing here, 0 and negative 2. Good, so let's actually add them. I've got 3x plus x plus 2. Can I just change that to 4x plus 2?
Yeah.
You can.
over x plus 2. Good, so now finish. Try and factor the top if you can. What can we pull out of the top?
2.
Yeah, just a 2, right? So 2. Leaving me with 2x, sorry, 2x plus 1, my bad. X plus 2. That's great, we factored it. Did it do anything? No. No. Sometimes you'll factor and it doesn't matter. We've seen it 2-3 times now where I factor and I can't actually simplify, right? Still factor. A lot of times my questions will say, perform the operation, simplify, if possible, leave answer fully factor. Okay? So the directions will actually say to factor completely. I didn't here, but you might as well do it. See if anything passes, right? Okay. Let's skip B.
Yay.
Go to C. That's a plus 3. Good. Okay, first step.
Factor your denominator.
Yeah, back of the denominator. What can I pull out of that first one? Pull out a 2, leave me with. No, just x minus 1. Oh, well, yeah, the 2 on the outside. Yeah, okay, good. Minus, I got a negative 2x minus 1 over x squared minus 4x plus 3. Yeah, negative 3 and negative 1. The negative 1 times negative 3 will be positive 3. Good. X minus 1. X minus 3. Good. So on the bottom, this is why I factor, right? Because now I see pretty clearly what I need. On the left, what do both of these denominators have in common already? An x minus 1. So what do I need to add to the right to make it look good? A 2. As long as I add what to the left? An x minus 3. So actually, the multiplication on this is just x minus 3, right? And right, because this will add a 2. No, and x minus 3. Doesn't matter what order they're in or anything, right? Good. So x minus 3, x plus 2 over x minus 3, 2, x minus 1 minus 2, negative 2x minus 1 over x minus 1, x minus 3, and 2. Okay. On problems like this, where I've got all these factors up in the numerator, you could distribute separately in FOIL, and then combine, and then everything like that. I think that's probably the way to do it. Honestly, there's no shortcut here. Ultimately, at any point when we FOIL and distribute, we're going to have to combine like terms. So I say do it now. Let's just work with the numerator for a little while. If I distribute this out, or FOIL, I'll have x squared minus 3x plus 2x minus 6, right?
Squared minus 6.
Huh?
X squared minus x minus 6. It's like once you add everything together.
Oh, you mean minus x? Yeah. We can do that now. Yeah, we'll just go ahead minus x minus 6. That's fine. Then this is minus 2 times negative 2 minus 1. So minus. Let's go ahead and get just this bit, and then we'll distribute that negative sign. So 2 times negative 2, negative 4x minus 2, right? That's just my numerators. So here's this big minus sign there. That has to be distributed. So I've got a plus 4x plus 2.
Yeah.
So hold
X
on.
minus 1 cancel on the bottom.
What?
And then 1 minus.
No, I don't cancel to the end. Somebody else would say restriction.
X 3.
Yeah.
And
Hold on. Well, let's combine these and then we'll restrict. Good. So I've got an x squared I've got a negative x and a positive 4x, which is plus 3x. 2 minus 4, so negative 4. Good, and that is all over x minus 3, x minus 1, and 2. Good, so let's state restrictions.
How did you get a negative 4?
Hold on, let's state restrictions because I haven't done that yet. What can x not equal?
1 or 3.
3, 1.
Whatever, not count.
Well, there's no x in it, so set 2 equals 0.
You can't.
2 division. Only factors that have an x in it. If that was 2x, I would say yes. 2x equals 0 divided by 2. But no, there's no x there. It's still important, and I need it in my problem. Lucky the negative 4 came from a negative 6 and a positive 2. You see that? Negative 6, positive 2. Yeah.
For mine, I got the numerator x squared minus 5x minus 8.
Think that's
Because x squared, because like the top is negative 4 minus negative 4x minus 2x I got.
negative 4.
You gotta distribute the negative.
You didn't. I don't think you
Oh, the
distributed.
negative
Yeah.
sign.
This negative sign got distributed there.
Wait.
This one right in the middle. So yeah, you did this. That's kind of why I do them separate, right? That makes sense. Okay. Good. So last step.
Well, yeah, for my numerator on the top left-hand one, I got x squared. I got a negative 1 is my number, not a 6.
Okay, that's wrong. What's negative 3 times 2?
Negative 6.
Okay. Cool.
Oh, what did I do wrong? Okay.
You multiplied 3 and 2 wrong. I don't know what to tell you.
Probably. Oh, I added it, so it's
Oh, negative 2 and positive 3.
yeah.
Yeah, that would be, or positive 2 and negative 3. Good. All right, so what can I pull, or what is that going to factor down to? Yeah, so x plus 4, right? X minus 1 over x minus 3.
At the very, very
Minus
beginning,
1.
you distribute your negative. You
Hold
go
on.
to the end.
Hold on, wait. So what goes away? Leaving me with x
Plus 4.
plus 4 over 2 x minus 3. That is a big old long problem, right?
Big ol'